Fine, we have done the exceptions, and so now let's look at the next topic. Okay, let's look at enums. Fine, look at enum. Okay, so today's topic is enum. So what is an enum? And we have seen it earlier also, definition part at least, yes. So what is an enum? Enum is it's just like a class. Fine, enum is just like a class, with the difference that in case of an enum, the objects are predefined. Fine, the objects are there, the list of objects is always available. Fine, so and users can't create. Fine, you can't create new objects. A fixed number of objects are always there for a enum. So it's just like a class only. Fine, it's just similar to a class. And since the objects are not going to be created, fine, can't be created, fixed objects, right? New objects can't be created. So one thing about enum is the constructors for enum, because it's a class, right? So this will also have constructors. The constructors for enum are always private. The constructors for enum are always private. Okay. Okay, we may have a look at the syntax. Fine, general syntax for an enum. Another point here. Okay, as we look at the syntax, I think we'll realize this. To define an enum, it's just going to be like defining a class. Okay, I will note the differences. Fine, where differences are available. So when I define a class, what do we give? We'll say we use the keyword class, instead we use the keyword enum. So maybe you want to define a public enum. So we'll say, okay, we have a public enum. Give the name of the enum. Fine. So syntax wise, yes, there will be some name for the enum which you want to define, just like putting a class name. Okay, this is just like a class name. And then in case of a class definition, what's the next thing? Extends. In case of enum, there is no extends. You can't give extends. Fine, extends means your superclass. Enum, any enum which you are defining always has a fixed superclass. Okay, there's a fixed given superclass which goes as a superclass for all enums. So in the java.lang package, there is a class called enum, capital E. Okay, fine, we have a class called, there is a class by the name enum. Okay, so we never have a syntax which allows us to specify a superclass. If it's a enum being defined, that means the superclass is the enum class. Fine. You can have implements. So just like any other class definition has implements, after extends it can have implements. So this can optionally have the implements followed by list of interfaces. Fine, comma separate list of interfaces. Fine. So fine, the declaration part, declaring that this is public or whatever. Fine. One thing for enum, since you will be having objects, you are not allowed to declare abstract here. Okay, you are not allowed to declare enum as abstract. You can have an abstract class, but you can't have a enum declared as abstract. Okay, it's a separate thing whether a enum can have abstract method or not. And that's a separate idea. We'll see that part also. Okay, fine. And then the body of the enum. So the difference between the body of a class and body of the enum is the body of a enum begins with the objects. It starts with the list of objects. For this enum, I will have so and so objects. So you may have a list of objects. Okay, so object list will be available. So first part is declare the object list. Okay, so let's take some example. Fine, let's take an example of a enum. Maybe you want to have an enum for the months in a Gregorian calendar. Fine, different calendar have different months, right? So let's consider the Gregorian calendar. Fine. So what are the months in a Gregorian calendar? How many months? 12 months. Okay. Fine. So maybe you want to give names to those objects. What are the names you may give to those objects? So I'll say, oh, I want one object whose name, the first object which I want. See, I'm saying the first object is to be named as JAN maybe. And I want that object to be created. Fine. Later we understand there is going to be a class definition. This is a class definition. It would have a constructor. And you may be interested in, you would be calling those constructor in order to create an object. So you're saying, okay, create one object whose name is Jan. The first object's name is Jan. And if the constructor here, which is going to follow later, has a parameter, you may pass that parameter. You're invoking a constructor at this point. So you're saying, okay, this, and the parameter to be used for creating the object. Maybe the parameter might be the number of days in that month. Okay, maximum number of days in that month. Maybe that's a parameter here. Fine. So you may probably do something like this, 31. Put a comma, it's a list. So you give, this is my first object. The name of the object is this, and the parameters for creating the object. Parameter to the constructor. So later somewhere, we understand after the object list, there is going to be a semicolon to give an end to the object list. It's a comma separated object list. End of object list is a semicolon. Okay, and then maybe what you might have is you can have the instance variable as a private variable, int for the max days, semicolon. This would be a semicolon, and then you might have a private constructor. And to have a constructor, what's needed? Now another point was, because it's an enum, this is, okay, what I'm defining is a month. Okay, I won't need the implements part. Fine. I won't need the implements part. For month, I'm not writing any, I'm not implementing some interface here. So it's a public enum month. There will be a list of objects, but I'm writing the second part also just to relate to what I'm doing here. Okay, so this is a private, one instance variable will be there. So every object of month has the maximum days in that month, and that object will have this, right? You will have a getter method for this, but you would have a private constructor, and the constructors are always private. Now even if I don't declare private, it's still private. So I can just say, okay, I'm having a constructor which requires a integer, and this would have the code, and this dot max days equal to that parameter. Maybe that's the thing which you might be doing. Fine. So your constructor requires one integer, so one parameter integer is needed, so that's what you are doing here. Okay. So when you are giving your object list, fine. So what is object list? You are listing these objects, they are in a order. Understand, they are in a order. This is my first element, this is my next element. So you are putting elements, your objects in an order. You are giving a name to the object. JAN, fine, that spelling is nothing but a name which is given to that object. Okay, and you are passing parameters to the constructor. Fine. This object is to be created with this as the parameter for the constructor. The constructor requires one integer and therefore I am passing this. Okay. In case you have a constructor without arguments, it's not even required to put the brackets. You can just, okay, so if I didn't have a constructor, if my constructor was without any parameters, I would have just said, okay, the equivalent thing would have been, maybe I'll just put this, JAN, comma, that's it. No need of brackets if the constructor didn't need a parameter. Fine. Okay. So you're giving a list of objects, right? So comma, and then you can, okay, so like this, you could be doing this. Maybe it's 29, comma. So I'm assuming we are going to have a constructor. It's fine. That's the kind of constructor you will have, which takes an integer, and you could give your list like this. Okay, maybe. The convention is you could be writing in one line, JN, fab, and all those things. But the convention is to have each one in a separate line. That's a convention. Okay, we put each object on a separate line. And the last one is December with the value of 31, and someone puts a comma, but that's not an error. Okay, you may put an additional comma for the last one. It's not needed after the last one, it's the end of the list, but if you put a comma, then also it's fine. Okay, fine. After the last element, a comma is fine. Okay, this just, the idea being that in case you are going to shift around those, maybe for a later part, maybe at some stage, for some reason, if you have to move some element up or down in your definition later, you don't have to worry about, oh, I have to put that comma there and again remove the comma from the last one. Something else goes to the last, and in this sense, you're shifting it somewhere. So it's just a small convenience which they have provided. Okay, so that a comma is fine even after the last element. Fine. So first part, object list, and what we are doing in the object list, remember, we are giving a name and we are putting them in an order. Why I am mentioning all this name and order is because of this. When you list an object, fine, you are putting a constructor here, fine. You create object of anything, any class, the superclass constructor is used, fine. The superclass constructor has some instance variables, they will need to be initialized, fine. The superclass constructor has instance variables and they will need initialization. Fine. The Enum class has two instance variables. There are two instance variables for the Enum class, and those two instance variables are, one is of type int, it's called the ordinal. So every enum, any enum type it may be, right? Any enum type. The object of enum has a ordinal value and it has a string which is nothing but the name. Every enum type has a name. Every enum object has a name. What you type here becomes the name of this object. Okay. See, there are lot many things. Though you write this kind of a code, there are lot many things which are happening. When it compiles the code, okay, one thing is, oh, it has to create these objects. Fine, there has to be this, so many 12 objects will have to be created, and in each of those 12 objects, since they extend from enum, the initialization for the ordinal value and a name will have to take place. So in those objects, ordinal value for Jan will be, the first object will be 0. Fine, it starts with 0. So ordinal values are from 0, 1, 2, 3, 0 to 11. Okay, they will get ordinal values of 0 to 11. And what's the name they are getting? So the first element gets the name of the string Jan. Whatever you have used here becomes the name. The enum class has given us instance methods. There is a method called ordinal, returns int. There is a method called name, returns a string. That's a method from the enum. Fine. Now there are actually two uses. There are two uses of what spelling you use here. This is used in two ways. One, we understand it's used in the, it goes as a name of the object. But how do I fetch that object? How do I access that object which is part of an enum? How do I access this object which is part of the enum called month? Anywhere I would like to use that first object, it's accessible as, so when the compiler compiles it, it is actually creating a static variable which is static and final, public static and final variable inside the enum. So month, the enum month now gets a public static final. What's the type? Month. What's the name of the variable? Jan. So month.jan is an object of the type month. The type is month. Okay, so on month.jan, right? So maybe I'll show a declaration. Fine, I'll just show a small declaration. Maybe I'll write it here. So in some place someone might write a code and say month m1 equals, and he says month.jan. That's fine. You could have any variable name. The type is month and it is month.jan. Okay, m1 dot ordinal. Ordinal is a method available on type month. It is inherited from the enum class. From enum class it is inheriting certain methods. Two methods which I mentioned are, one is a method called ordinal, other is the method called name. Okay, so every object which is listed here has an ordinal and a name. Okay, Now a few things about the enum, because what you are inheriting, what can be done on that M1, okay, oh, it implements. So enum says that enum is implementing this enum here, right, that enum class, you don't mention it here, you don't need to basically. Enum implements comparable. Enum implements comparable. If you have got another month M2, you could say M1 dot compare to M2. Okay, fine, M1 dot compare to M2. Someone might think of maybe, because I can write the definition part, someone might think of overriding the name method. I don't like that name as this. I want the name to be January, full spelling. You can override, can we? No. We can't override. Why? Why we can't override the method called name? Huh? It is extending, it is a subclass of enum. This is a subclass of enum. Final methods cannot be overridden. Most of the instance methods in enum are final. Okay, so most of the time they are final. So what are the methods you can see? Ordinal, that's final, can't be overridden. Name, that's final, can't be overridden. Fine. Compare to, because it implements comparable, that's also final, can't be overridden. Fine. So you might like to change the logic of comparison. You might have listed in one way, but you said, oh, let me have the logic of comparison in some other manner. No. At least the natural order is the way you have listed, that is considered as a natural order. And the order in which you list the objects, that's the natural order for the enum. Fine, compare to. Another thing, a new object, you understand, it can be created. How can a new object of a particular class be created? One is calling the constructor. Constructor, whether you declare or not, it is private. So from outside it can't be, no one can create an object. But there is another way, without using constructor, that we can create a new object. We did for cuboid, which was with composition. How a new object can be created? Huh? New object can be created. Now in composition, the cuboid, we had two cuboids. So I'm mentioning the cuboid with composition is the one where we did this kind of a thing about creating a new object, but we didn't use the constructor to create the new object. It wasn't with the help of new, but we could get a new object. You had used a method on that object to create a new one, to create a copy. I mean, creating a copy is a separate object, right? What was that method? Clone method. Fine. So, you know what has been done? They have a final method called clone. The enum has a final method called clone, and what is done in that clone method? Throw clone not supported exception. It's final. So anyone writing an enum will not be able to override. That's the whole idea. You don't do anything with clone here. It's not going. No one. We don't want to allow clone for anything. Clone means creating a new object. No cloning. So they mentioned that enum implements, this enum class in its definition says it implements clonable, but what it does in turn is the clone method is implemented to throw a exception and taking care that no new object can be created. Fine, so methods are final. We do have the toString method, which is not final. The toString method is not final. Fine. ToString method is not final, and that can be overridden. By default, ToString method returns the name. Fine, ToString also returns this name, the string. Fine. So for enums, fine, methods, you know some methods now. Plus the additional methods will be the methods which you are defining here. Enum definition in two parts. First part, list, semicolon, class, a class definition. Fine. Many places, maybe you don't want anything, whatever is there in the enum you have inherited, there's nothing more than that you want. Okay, you don't even put a semicolon or anything else, that's it, just you put a comma separated list. That could also be a simple enum. I'm not interested in maximum number of days or anything, but just a list of objects, Jan, Feb, and that's sufficient. Okay, that's fine. Days of a week, okay, Sunday, Monday, Tuesday, everything, right? Maybe there are no additional attributes I want on them. Okay, so 7 objects listed, that's the days of a week. Fine, clear? What's there in an enum? List and a class definition. So enum is a class which extends from the class called enum. Another point, this enum is a special class, and when you define a class, though enum is not a final class, okay, enum is not anyway not a final class, but still you can't create a subclass of the enum. Fine. Compiler does not allow you to create a subclass of the enum class. Subclasses of enum are defined by using the keyword enum. You only define it as a enum type. Fine. So enum class is available. Okay. Fine. Enum class. Okay. So one point is about the methods which you have inherited from the enum class. Those are fine. Okay. There will be a few steps. Yeah.
Compared to method final, so
Yeah.
how are you defined to the method?
Who? Oh, I'm saying it's final inside the enum class.
Actually, I'm overriding the
No, you can't.
सर हमें order change करना हो
यहाँ पे order रखो ना. Whatever order you see, you are supposed to give a list of objects. Whatever order you put there, that's the order. That is the order. If you are doing a sort of these objects somewhere else, you have some array of month objects. You don't have 12 objects maybe. And you may have certain objects which are of the type month. And you are saying sort them. Okay, they'll be sorted. The comparison will be based on this, the way you have listed here. And the comparison on the, so ordinal values, that's the value used for comparison. Fine. Ordinal value. So as you put your elements, you are giving ordinal values to them, starting with 0. Fine. So enum class has put the compare to method as final. So from enum you are inheriting some variables, that's fine, but there are some static methods which the compiler introduces within your enum. You don't have to put those methods are pre-created. Fine. When you compile any enum type, okay, so I'll take the example of month in this case, you get two static methods. See, there will be 12 static variables for the 12 month objects. The objects are there as they are public static and final variables. Fine. So that's why you are saying month.gen. So there are 12 static variables. Fine. So all these objects are available by using that variable name. Fine. Plus you have two static methods. One static method to make available all the objects together as an array. So you have a static method, so I'll push this up. Okay. So now this is for what you get. You are not going to be defining them. Okay, I am mentioning these methods. You don't have to put them anywhere. These are there. These will be there for you. You will be able to use this method. Fine. I am giving you the method signature, but you don't have to actually put this. It's there in your enum because it's an enum called month. So the enum called month has a static method. It gets a static method to return. It's a public and static method to return an array of month. I want all the month elements. Fine. The name of the method is the name of the method is values without any parameter. So if I say month.values, I get an array of month containing all the listed objects. Fine. So any enum type is there. Fine. That enum type dot values gives me the objects of that array containing the objects of that type. Fine. So in our case, this is month, and therefore such a method is there. So we don't declare such method inside your enum. Okay, it's already there. Fine. Compiler is doing this for us. Okay, so you don't have to declare this, but you should be able. So because of this, fine, don't declare. Fine. So because of this, you should be able to do something like month array all months is equal to month dot values. Fine. So if you are interested in getting all the objects of a enum, right, in the form of an array, and that's a code you will write. This is a valid code. Okay, fine. This is not to be okay. This is just for understanding why you are able to use this. Fine. Now every enum has got a name. Every enum object has a name, and you have specified the name there. Fine. So you also have another static method which returns a month object for a given name. Method name is value of. Parameter is a string, the name. So if you give a name, you should be able to obtain a month object. So given a string, name is a string. Fine. So given a string, you should be able to fetch the object of the enum type. which has that name. Fine. If you don't have an object with that name, it should return a null. Fine. This should return a null in case there is no object with that name. Fine. So from usage point of view, you could say, okay, month m or m1 equals month dot value of O is capital, and you pass some thing which you have received from a user. Maybe user has specified which month he wants to work on. Right? So that should be a string variable. This should be a string, and you get the month for it. And then you can, from that m1, you can use the method called getMaxDays or some such things, right? What's the maximum number of days there? You might have, because it's a whole definition, you might have added lot many things inside your class definition part. You have your own public methods here, additional methods, anything whatever is there, fine, that can be done. You fetching object by name or fetching all the objects. So two static methods are added to your enum type. So every enum type gets two static methods. Those two static methods you don't have to declare, don't have to write the code for that. Okay? Fine, clear? Okay. Fine. So someone says, let's override. So okay, let's try to define the enum for month. Yeah. Okay, so let me write the code for this maybe. Okay, so we can have a package maybe. Let's call the package as util, fine, where we might define a public enum for month. Okay. And yeah, so maybe we list those objects, or I'll put the class definition first. Okay, I'll put the class definition, then we can have the list. Okay. So in the class definition, I will have maybe a private variable for max days, fine, and maybe by default initial value is 31. Okay. Or even if it's, I don't put initialization, then it will be fine. Let me add constructors. Constructors, so you may explicitly declare private, or even if I don't declare, it is going to be private. It takes fine, but I add another constructor, and which is without any parameters. So by default it is 31. Fine, you have overloaded constructor, right? Fine, there is that constructor overloading. You might even add a public method, returns int get max days. Fine. Return this dot max days. And that's what we have done. So we have such methods, and now let's put the list. Okay. So here I say Jan and put a comma. Default is 31. Okay. Feb. Yeah. We have 29. March. April is 30. Oops. Fine, you could be listing like this. Okay, fine. So this is a simple enum for month. Okay, and then it's just like a class definition. I can have a main here also. When we can have a main, so let's have a main. When you could put outside or anywhere, right? You could have it in a separate class where you write a main method, or even inside a enum, public static void main, and we use, okay. So maybe from command line I'll take the 3-letter month name, okay. So I'll say string month name equals args of 0. Fine. Month name is args of 0, and then yeah, we want a month object for it, right? Month equals let me do one more thing here, dot toUpperCase. It's a method in the string. toUpperCase is a method in the string class, right? To convert it into uppercase. Return a new string object with uppercase. Okay. So we are fine. We have the convention is to use all uppercase for the enum names. And so I convert to uppercase, and then I can use it in value of and pass the fine, get the month object, and then I'll print the message yeah. Month plus equals has fine. That's a very simple thing. Fine, this can be done. Fine, we are using the value of method. Fine, we don't have to define it inside the enum anywhere, okay? Straight away use it. Fine, all enums have the value of method. all enum have the values method. Two static methods will come. Fine. So, fine. Okay, now we could be actually doing a slightly better thing than this. But is this clear what this should be doing? Want to see the output and things running? Okay, let's check this then. That's a package called util, and we have the month.java. Okay. Okay, so let's compile. And so this compiles, and it has a main, so we can run this. Okay, this will need a command line argument. Okay. Fine. A very simple thing. Okay. From command line you can give a name, and for that name it should be giving us what's a max days. Okay. I don't like that FAB capital, right? कहाँ पे? हाँ, we get the null point exception. Illegal argument exception. Oh, it's giving us the, see what has failed, the value of itself fails. It's so it's one thing, it's the value of is not returning a null. Remember, the value of is not returning a null. It's saying what you have given is not a valid name. It gives you an error and not giving you a null object. Okay, the value of is not giving a null, instead it straight away fails, saying, oh, you have not given me a valid. Illegal argument exception. See, I was talking about that yesterday. And your parameter value is not a valid one. Fine. From the stack trace you can see main called value of has called the month dot value of has called the enum, also has a static method called value of. Fine, which is called from this enum, and that has returned a, that has thrown an exception. Fine. So spelling has to be, what we did was we followed all uppercase as a convention, and then we have whatever command line you give will convert into uppercase and use it. Okay, so it has to be a valid name. Fine, what you give should be a valid name. Okay, so not for the purpose of taking a name, but for the purpose of output, we may like to have the name of the month here. Month has only max days. Our month object has a name which comes from the enum name. fine, from the superclass. But we can introduce our own name also as one more variable, fine, the name of the month, where we can have the full name, fine. Let's keep that in short only, those 3-letter names are fine, okay. But let's add an attribute for the full name, fine. What's a full name? So we can have one more instance variable to store the month name, and then you may have a constructor in that manner, okay. So we might have, so let's add this, right. So we would like to add a private string name as a instance variable. Let's update our constructors to, okay, fine. Oh, we can't have a default constructor now. Fine, we'll have to specify the name. Fine, we'll pass that name. Okay. Our object creation will have to change, and add another method. Fine, one more public method returns a string get name. Fine, that method was name. What you are inheriting as the method name. So we have this method called get name. Oh. Okay. And our output can then be, instead of month plus month name, month dot get name. Yeah. Let's compile. And we're done. Yeah. Fine. Okay. Now, maybe for some object you want something different, right? In case of months, okay, Fine, this is fine. So far, the syntax part. Okay. Now, let's come back to the board and explain on the board here. Okay, so syntax wise we have seen certain things, right? Now I'm going to introduce another new syntax here. Okay, for that let's take another example of an enum. Fine, another enum. So maybe we have a enum. Enum means something which has fixed number of objects. Okay, so we have this object of arithmetic operator. We might have enum for arithmetic operator. Oh, what are the arithmetic operators? Addition, subtraction, multiplication, division. Let's define an enum for that. Okay. Fine. So we want to define enum for arithmetic operator. So we'll say, okay, it could be that package util, and you are having a public enum for arithmetic operator. Right? We're not implementing any interface. Fine, but if there was a need, we could be doing that. Fine. So what are the arithmetic operators? Addition. So maybe let's use those three letters: add, add. Yeah. You can have an instance variable for the symbol used. So you might say, okay, this uses a symbol called plus. So that's taken in the constructor. Okay, now another thing, every arithmetic operator, I would like to have a method called compute. For the arithmetic operator here, I would like to have a method called compute. So add.compute, and I'll pass two double values and get a double value. Fine. So I would like to have a method called compute. I'm jumping to the, I'm not finishing the list currently. Okay. I'm jumping to the class definition part. So within that class definition, after the semicolon, one thing is I would have a private string for the symbol. Fine. Whose initialization is done using a constructor. Fine. You will have a constructor with a string as a parameter. Fine. So we have used the constructor, taken a string, symbol is available. Okay. But we would also like to have, so other things are there. Fine. The relevant things for the symbol thing taken care of, the constructor and the get symbol method. Fine. Maybe you have a method called get symbol. Now let's add a public method. Okay. Returns double. Name of the method is compute. Parameter is double a comma double b. Yeah. How do we write this code? How do we write this code? Code for compute. Oh, it's different for different object. There is this common method for all the objects of the enum. but the implementation of this method is different for each of them. Right? Or it would be a very complex if structure, right? If is a complex thing. Fine. You would have to say, oh, if this dot name dot equals add, then return a plus b. If this, fine, you'll have to check the name on the current object and then decide to return a different expression, right? Instead, the option would be that each object has its own separate compute method. Okay, but I will need, so on the type arithmetic operator, on the data type arithmetic operator, I need a method called compute. I need a method called compute, so that any arithmetic operator is there, on that I can call the compute method, but I am not writing the implementation here, okay, making it abstract. But then where does the compute method go? The compute method goes with the object. The compute method goes with the object. So for this object, oh, there is an abstract method here. Oh, that's for this object add. Fine. I am creating the object add where. So I start braces now. Where I am overriding for this object. I override. Fine. Public double compute double A comma double B, and I'll simply say return A plus B, the end of the method, and here's the end of my object's definition. When this is where I started the definition, and that's the comma, that's my object. The object list syntax, general syntax. Position decides the ordinal value, that's the first one, ordinal value 0. I want an object with ordinal value 0 whose name is add. I want to create this object by passing a value of the symbol as plus, okay, and in this case I would like to override the compute method to compute like this. So here is how to override a method for a given object. For any object, fine, you can, while creating an object, so this is, how you are creating the object. While creating any object, you can override a method which is not final for that object. When you are creating the object and you are overriding a method, it need not necessarily be an abstract method which you are overriding. In this case, it's an abstract method which you are overriding, fine, but not necessary. Okay, I'll show you this syntax in general now. Fine, this syntax I have shown for Enum, but my statement was more general. I said while creating any object, fine, you can override a method for that object. What it means, okay, So just the syntax part again. I'll give an example so that you understand the syntax. You are creating an account object. Account AC1 equals how do we create an account object? New. Okay. Call the constructor of, okay, maybe it's account itself. Oh, account is abstract, but right? But still it's fine. Still it's going to be fine. Okay, I could be saying, okay, new account, use the constructor of account. Account for James. Fine, you have some parameter. Okay, call the constructor, but don't stop. Your object is not yet over. For this object, override. Override public void deposit. Fine. Long amount. You have the throws, negative amount exception. Fine. Fine. And then write your implementation of the deposit method. So you have something different being done here maybe, and you deposit to something else. Fine. End of the overriding method, end of my this thing. Yeah, and that's it. Semicolon to end the statement, the assignment. It's a general syntax. When creating any object, for this object I want to override a method. Oh, that's possible. So with AC1 dot deposit, the deposit is going to work like this. Other methods are inherited from the account. Oh, it's an object of some subclass of account. Okay, it's not exactly the account, right? Because it is a different definition. Some methods behave differently. There are some methods which are working differently. There's some additional thing. It's not exactly account. It is something. It is a kind of account only. It's a kind of account, not exactly account. Find the syntax. New, whatever you want, just call the constructor, but don't end there. Start your definition of a class and put the things there. This is actually a class definition. Okay, you are defining a new class. Okay, but you have not given a name to that class. So you are straight away creating object of a class whose name has not been created. So I have not given a name to the class, but you want to create object of such a class. It's not the account class, and this is not exactly the account class, but a kind of account where deposit works like this. Okay? Clear? A new syntax. This is anonymous class, syntax for the anonymous class. But it's only when you are creating the object. And this happens when you create a new object. Fine? Okay, coming back to the enum. Yeah. Yeah. So within enum, enum may have an abstract method also, okay? But if it has an abstract method, every object in that list will have to override. Fine. Object level method overriding is always possible. Fine. So, how is the arithmetic operator going to be defined? Is also clear? Fine. Same way, earlier we did what? The month, the enum for the month. For the month enum, if someone wanted, fine, you could have overridden the toString method. Or for this object, I want to override toString method, right? Or that was also possible. Fine, this syntax is clear. I want to try this out now. Arithmetic operator. Fine, we can try this. Okay, I'll show it. Okay, so let's define the arithmetic operator and do something there, right? And what are the things? We have the private string, one is the symbol, and we have got the constructor. Okay, so constructor for arithmetic operator takes a string, it has the public method string get. That's it. Fine. And then maybe we add a main method here. Okay. Yeah. What goes in the main? Okay, so we take what? We'll take the name of the operator, 3 letters, and then 2 more command line arguments which goes as the values for A and B. Okay, the 2 parameters to invoke the compute, and then we'll print the things, right? So we'll have a string, operator name equals args of 0 dot to uppercase. Fine. Next, operator name is there. We'll have double A equals, okay. Now, just like we used integer dot parseInt, we have double dot parse double. In the double class, parse double is the method which can convert a string to a double. Okay, this will also throw number format exception. Okay, args of 1. Okay, so we got 3 things, right? 3 command line arguments, and then we would like to print a message saying, giving the result. So system.out.println A plus space plus, oh, before that we'll have to do one thing. We'll have to get the arithmetic operator for us, right? Equals when getting the operator. Fine, and then straight away you can say, okay, we can do the, yeah, so what do we do? Operator dot get symbol plus space plus B plus
उसमें नहीं है
कहाँ पे?
A और B
This is A and B which we have got from the command line.
डबल है ना
हाँ डबल है टाइप, तो वो प्रिंट कर रहे हैं ना इधर,
हाँ इधर कोर्स में नहीं लिखा
ये नहीं आएगा ना, दिस इज डबल टाइप, कोड तो स्ट्रिंग हो जाएगा ना वो, उसका वैल्यू ए का वैल्यू, द वैल्यू ऑफ ए, लेट्स सी द आउटपुट.
सर उधर ऑपरेटर का स्पेक्टर
कहाँ पे? ये लाइन में? ऑपरेटर fine. Okay, so let's save this as okay, so let's compile. Oops. And compiles, and we'll have to pass 3 parameters. So maybe we want to do multiplication, multiply 75 74.3, it's a double, right? 223.7. Fine, or you want to try something simple so that you can verify? Try addition. Fine. You can see something here, note something. There's no if statement anywhere. There's no conditional statement at any place. See, we don't need a condition. We got the object has its own method. Each object has its relevant method. Fine. Otherwise, recollect, we would have a complex if statement, right? Checking, if we had to write instead of declaring abstract, right? Switch case or something. There's no switch case. Where is the switch case? नहीं है, conditional नहीं है कुछ भी. Except for one thing, we have used the value of method, and understand that inside the value of method there would be some conditionals. Okay, that has been hidden from us now. And the value of method, you are giving a name and then it has to find which object it is. And that's probably the only conditional thing. कौन सा? Value of? It's available. That source code is available, and just need to check because after Java 8 they are not shipping the source code with the JDK. So someplace I do have the Java 8. Let me check if it is there. Oops. They have the code, but it's not shipped with the, it's not part of the JDK. I'm not sure what SRC is this. Yeah, there is this src.zip, okay, and I think I have extracted already into an src. So you want to see for which one? The value of, okay, the value of for enum. See, there is this value of the enum, we haven't seen the whole of the enum. Okay, enum is actually a generic class. Fine, enum is a generic class, it's not just the enum. Okay, I'll just show that. It's in the lang package, and here we would have the enum.java here. Okay. Fine, you can see it here is enum enum of E extends enum of E. It's a recursive, right? Generic invocation. So this is nothing but some enum only, enum of E, which is a enum. So this E basically is whatever enum type you are defining, right? Implements comparable and serializable, and it implements comparable, and it has a name. Fine, we understand name. It has a fine get name method. It has the ordinal. This has got the ordinal method. Fine, you can see these are final methods. This is the constructor for enum, simple thing. Fine, initializing the variables. ToString method is not final, but returns name. Equals method, just check for it being the same object. Hash code, super.hash code. Object class hash code, fine, basically. Clone method, throw new, made it final, so you can't override. That's the whole idea. Fine. No, this src which I am looking at, right, it's not available as when I install JDK, you get this src.zip file, which I have extracted and I am seeing from there. I don't think src.zip is now available along with that. You'll have to go to their site, and it will be available in OpenJDK site. Okay, so this compare to also final, you can see, and compare to is based on ordinal value. See, compare to returns based on ordinal value. Before that, he is just checking whether they are of the same type or not. Get declaring class, these are some final. This is the static value of method, where there is a parameter for the type class and the name. This class is nothing but your enum type. Okay, fine. This, you know what this method allows us to do? Okay, if I have to do this coding, sorry, I should be here only. Oops. Sorry. what this would allow me to do is something like this. One way I have fetched the arithmetic operator is like this. Fine. There is also, because I mentioned those two static methods, they come automatically. So that code anyway you can't be seeing now. Fine, you can't see, it's not, but this is Enum class. What we are looking at currently is the super class, Enum class. But those two static methods I mentioned, they come by compiler. They come into your Enum definition by the compiler. Okay. But हाँ, वो value of method क्या है? It has two parameters and not one parameter. Okay, fine. I'll just show. You could have done something like okay. Only one thing here is you will have to do a casting. Cast to actually casting की जरूरत तो नहीं पड़ना चाहिए. You will not even require the casting part, or will it be needing? Sorry. Fine. Here is that Enum. Class, the Enum type, that is arithmetic operator dot class. You know, for any type you just say dot class, you get the class object for it. That's a class object. Get class तो object class का class है, but you put dot class, int dot class or anything dot class is the class object. Arithmetic operator is a class. The Enum, it's a Enum. So dot class, for anything dot class you get a class object. So it's a class object for the arithmetic operator. So that becomes a, so return type is t here. See, the value of returns t. Fine. So even if I do like this, that should be fine. Okay. So I can obtain in this manner also. And so this one is not using the it is fetching the same object, okay, in any case. Okay, so both are basically the same object. One is using the value of method which is generated by compiler for me in the arithmetic operator itself. Other is the static method which is in the Enum class. This is the static method of the Enum class. Okay, which is being used here. So, okay, let's save and try this. Fine. So we can do. Fine. We will be getting two outputs. And so that compiles. And if I run this, it's the same results anyway. It's basically same object. Fine, but this time we have used the static method of Enum class. OPER1, that's using the static method of Enum. So with Enum, so Enum dot value of, that's also available, and specify the class object and the name for it. So for any Enum, give the class object and the name and use it as a static method on Enum. But anyway, we always have whatever Enum type is there, we always have the value of method there. Fine. And two static methods are inserted by compiler. I mentioned those, values and value of. Okay, fine. Fine, clear with this? Okay, so JDK 8 download and you should get that src.zip. Okay, fine. But that would be for JDK 8. Huh?
JDK 12 में भी आना चाहिए ना सारा ये सब classes.
Then go to OpenJDK. Search for OpenJDK.
सर कोई भी JDK हो मैंने डाउनलोड किया मेरा.
नहीं.
तो वो सर कैसे फिर?
नहीं, Oracle has a different policy now after Java 8.
सर क्लास तो चाहिए ना एग्जीक्यूशन के लिए.
Classes are there, na? For you don't need the Java file, right? You don't need the Java file. You need the class files. They are there in the jar files. That's good. Fine. But this is your Java, the source code. Huh? You can look at object.java. You can look at string.java. All those things. The source code for all your library classes are available. Throwable. You have seen throwable? Throwable.java is also there.